Hi students, welcome to my channel. This video is useful for 8th standard onwards. Okay, this is class number 91. What we are going to do in this class is, we are going to calculate the center of mass of an extended object. Extended object means what? It's very simple. You see this pen. This pen is a extended object. For this pen, how we can calculate the center of mass? Okay, for that I have given one example. See here, we have to take one reference frame, that is coordinate system, x-axis and y-axis. This is origin. One object is lying along the x-axis. I am cutting this object into small slices like this. For each slice, m1, m2, m3, m4, m5, m6 and m7. So I cut this object into 7 parts. Each part mass I have written. Each part is at a distance of x1. m1 is x1 distance from origin. m2 is x2 distance from origin. And so on. m7 is at a distance of x7 from the origin. For this situation, for this problem, the x coordinate of center of mass, that is xcm, equal to m1 x1 plus m2 x2 plus dash dash m7 x7 divided by m1 plus m2 plus dash dash m7. So this is the basic formula we are using to calculate the center of mass of a system of particles. But here these particles are very close to each other. Okay. So this m1 x1 plus m2 x2, this we can write as a summation. This symbol you are seeing, no? This is summation over mi xi. I is a variable type. Means that you can change. You give I equal to 1, 2, 3, 4, 5, 6 and so on. So summation over mi xi, I runs from I equal to 1 to 7. I equal to 1 means m1 x1. Summation no plus. I equal to 2 means m2 x2. Summation means plus. And so on. So here 7 particles are there, no? 7 slices are there, no? So up to 7 I am writing here. I equal to 1 to 7, this summation will run. Okay. Similarly, in the denominator, summation over mi. I equal to 1 to 7. So 1 means m1. 2 means m2. m1 plus m2 plus m3 plus dash dash m7. So we can simply write this m1 x1 plus m2 x2 like this. Summation over mi xi. I runs from 1 to 7. Okay, divided by summation over mi. I runs from 1 to 7. You understood now this? Similarly, for n particles, there are n particles. You divide this pen into small slices. So the total number of slices, that is n. So I am calling n particles. So center of mass x coordinate xcm equal to summation over I equal to 1 to n mi xi divided by summation over I equal to 1 to n mi. The summation means you are adding this term mi xi. Suppose I equal to 1 you put, so m1 x1 plus I equal to 2 you put, m2 x2. So this is nothing but m1 x1 plus m2 x2 plus m3 x3 and so on for n particles. So this summation means you are putting plus in the middle. So m1 x1 plus m2 x2 plus m3 x3, that is due to the summation. So that is why you are writing the symbol. This is summation. Okay. Now this summation is approximately equal to, when this mi is very small, so we can replace the summation to a integration. Integration means you are adding these two terms x and dm. Okay. Here dm is nothing but just like mi. When mi is very small, when you are cutting this pen into small slices, each slice mass is dm. The dm is at a distance of x from the origin. So m1 x1 I am writing dm x. Why dmx? You see here this graph. This is x-axis. This is y-axis. This is just like a pen. I'm putting along the x-axis. I'm cutting this pen into small slices. So at a distance of x from the origin, this part, this slice mass is dm. This dm is at a distance of x. So like this, you can cut this like here, one more. You're adding all together. So x dm. So that's what this x dm is, nothing but just like m1 x1. So you have to integrate, means you have to add from here to here. So this is the limit 0 to total length is L. Suppose this total length is L. From 0 to L you have to add. So I am putting the limits from 0 to L. This is lower limit, this is upper limit. Integration of x dm from 0 to L. So this is nothing but summation of this. So I can write like this. Integration of x dm 0 to L. This integration of dm means you are adding this all parts, dm here, this part, all you add, you will get total mass. That is a capital M. That is why we are going for integration. You got it, no? We will further, we can explain this. You watch forward. See here, center of mass of an extended object. I am using here integration. Integration is definitely for 8th standard, 9th standard, you will not understand. But you keep watching this video. So when you come to the 11th standard, it will become easier for you. It is not tough. It is not tough. This is IIT foundation, that's why I am introducing this one. Okay, how I am coming to integration, I will tell you now. This center of mass of an extended object, x coordinate I am writing like this. This summation already you understood, no? Summation over I equal to 1 to n. Suppose n particles are there. So I equal to 1 to n you can write here. MIXI divided by total mass. Directly I can write capital M. Capital M is the total mass of the system. Okay. So this Mi tending to 0. When you are cutting into small slices, no? Extended object is there. Just like this pen, you cut into small parts. Each part mass is Mi. So Mi tending to 0 means the mass of each slice of this pen is very small. Tending to 0 means very small. It's not equal to 0. Tending to 0. So you are cutting this pen into very small slices. That time the summation we can write as a integration. The summation as integration. Integration over the small mass I am calling dm. This dm is at a distance of x from the origin. So just like MIXI, Mi is replaced by dm. Xi is replaced by x. Means small slice of this pen, that is dm, at a distance of x from the origin. So you are integrating. Means you are just like adding only. Integration is nothing but adding, summation only. So this summation we can replace by using integration. This 1 by m, why I am writing, this is divided by m is there, no? This is a denominator. So I am writing 1 by m. Integration of x dm, that is equal to summation over MIXI. Simply the x coordinate of center of mass xm equal to 1 by m integration of x dm. Similarly, it can have y coordinate also, z coordinate also if you go for 3 dimension. So y coordinate I am simply writing like this, limit as mi tending to 0, summation over mi yi divided by capital M. This 1 by m integration of y dm you can write. Similarly, z coordinate zcm equal to limit mi tending to 0, summation over mi zi divided by capital M. That is equal to 1 by m integration of z dm. Like this, we can find out x coordinate, y coordinate and z coordinate of the center of mass for extended objects like this pen. You got it, no? See here, based on these formulas, we will solve one problem so that you will understand very clearly. One problem is like this. Find the center of mass of the stick as shown in the figure. This is a stick. length is 6 centimeter. I kept this stick along the x-axis. So this is x-axis, this is y-axis, this is origin. So the total length is 6 centimeter. This stick, the lower limit, it starts from origin, that is 0, ends at 6 centimeter. Okay, now we are going to calculate the center of mass x coordinate only because it is lying along the x-axis. For that, what you have to see, the linear mass density, mass per unit length, means in this length, suppose this small slice dx, in the dx width, how much mass is there? Mass per unit length, that is called linear mass density. First step, you have to take this. I am calling this mu, mu, this symbol equal to capital M by L. Capital M is the total mass of the stick. L is the total length of the stick. So capital M by L, that is linear mass density. Why we want this? To find out what is the mass within this width, dx. Within this width, what is the mass we should know. So that is dm. Dm equal to, we can write mu into dx. Mu is mass per unit length into length, that is dx. So this together, it is a mass, that is dm. Okay. Now x coordinate of center of mass is equal to 1 by m integration of x dm. This formula I told you. 1 by m I am writing integration of x dm equal to, I can write mu dx, mu into dx. Mu is a constant, you take out mu by capital M, integration of x dx. You know the formula, integration of x to the power of n dx, that is equal to x to the power of n plus 1 by n plus 1. Here x to the power of 1 is there, 1 plus 1 is 2, x square by 2. So mu by capital M, this is x square by 2, that is integration of x dx. Lower limit 0, upper limit L, you substitute, upper limit you substitute. This is mu by m, you write as it is. In the bracket, first upper limit L square, x place replaced by L. So L square by 2, minus x place replaced by 0. 0 by 2 is 0. So you can write it like this. Center of mass x coordinate is mu by capital M into L square by 2. Further, we will simplify it. That is x coordinate of center of mass mu L square by 2m. Mu is linear mass density. It is a constant, that is capital M by L. So mu L square by 2m equal to, this mu is nothing but capital M by L into L square by 2m. L square by 2m. This L, this square will cancel. What you will get? This m cancels. What you will get? L by 2. So here L is 6 centimeter. Okay. XCM is equal to 6 by 2 equal to 3 centimeter. That is the x coordinate of center of mass. So for a constant linear mass density, the center of mass of this extended object is at the center only. Total length is 6 centimeter. The center of mass is 3 centimeter. It means exactly midpoint of this pen. You got it now how to solve center of mass of an extended object after watching this video. Practice. Understand. That is enough. Okay. Thanks for watching.